Hi and welcome to E-ZTutoring. Today we're going to cover systems of equations by elimination. Now I'm sure you guys know there are two methods to solve systems of equations. The other method is by substitution, which I will cover in the next video. Anyways, let's suppose we have x plus y equals 10 and x minus y equals 6. I'm going to start off with a very basic example here. In this example, what we want to do by elimination is we want to cancel out one of the variables. Now the reason for that is in this top equation we have an x and a y. You cannot solve an equation when there are two different variables in there. Same with the second equation. However, if we can cancel out either the x's or the y's and be left with either only x's or only y's, then you can solve the equation. So that's the concept behind systems of equations. Now, how do you do that? Well, what you do is you pretty much just add the two equations together. And you add all the columns together. So when you add them together, we will do the first column, which is x plus x. And we get 2x. And then in the second column we get y minus y, which is nothing, which is exactly what we want, plus 0. So just like that, we canceled out the y's, and now we are left with only x in our new equation. And then of course we do 10 plus 6, which gives us 16. 2x equals 16. Divide by 2, x equals 8. So that is how you cancel out one of your variables. Once again, like I said, this is a very basic example. I will jump into a more complicated one in the next one. But anyways, we found x. How do we find y? Well, we don't have to do all of these steps again to find y. Now that we found one of the numbers, what we can do is we can actually take this equation and plug in for x. So it says x plus y, but since x is 8, this becomes 8 plus y equals 10. Subtract the 8, and we get that y equals 2. And just like that, we found both of our variables, x and y, 8 and 2. And the cool thing is, you can actually plug in x into this equation as well, and, whoops, I did not mean to put a parenthesis. You will get the same exact answer. So let's say we add y over here, add y, and also subtract the 6, so we get 2 equals y. You get the same exact answer. So anyways, let's jump into one more problem. Okay, so now suppose that we have x squared plus 2y squared equals 33, and we have x squared plus y squared minus 19 equals 2x. There's a lot more going on in this system of equations. So we really have to analyze this, and we really have to think about this before we start solving. Do we cancel out the x squared? Do we cancel out the y squared? Or do we cancel out the x? Well, if we cancel out the x squared, we'll be left with y squared and x. Can we solve an equation with y squared and x? No, we cannot. If we cancel out the y squared, we'll be left with x squared and x. Can we solve an equation with x squared and x? Yes, we can. That's a quadratic. So we want to cancel out y squared and 2y squared. But you'll notice in the last problem, it was just y minus y. It was so easy to cancel out. Now it's not that easy. How do we cancel out 2y squared with y squared? Well, if this were negative 2, it would be so easy to cancel it out, because you would just have 2y squared minus 2y squared. So what we want to do is we actually want to multiply this by a negative 2 so we can get the y squareds to cancel. Now if we multiply that side by -2, then we also have to multiply this side by -2. So our new system of equations will become -2. Oh, whoops, I should do the top one first. So let's say x squared plus 2y squared equals 33. And then we have -2x squared minus 2y squared plus 38 equals -4x. So now we can go ahead and start eliminating. X squared minus 2x squared gives us a -x squared. 2y squared minus 2y squared is nothing. This cancels out. We are done with the y squareds. And then we have the plus 38 and nothing over there, so we just put plus 38. And on this side we have 33 minus 4x. Okay, so now all we have to do is a little bit of algebra, solve this as a quadratic, and we're done. So let's go ahead and subtract the 33 and add the 4x. So we get -x squared plus 4x. Oh, whoops, I put plus 33. I was supposed to put minus. Plus 5, and this is equal to 0 now. Now multiply all this by a negative. And of course, you can multiply the right side by a negative as well. It won't change the fact that it's 0. And now you just have to factor this. I'm not going to go into too much detail on how to factor. I'm going to assume you guys are familiar with how to factor a simple quadratic. So let's see, what will we get here? X minus 5 and x plus 1. So x equals 5 or x equals -1. So what we're going to do is we have to find our corresponding y values. So in order to do that, we plug these in one at a time. If we plug in the 5 for x, we will get 5 squared, which is 25, plus 2y squared equals 33. Subtract the 25, we get 2y squared equals 8. And divide the 2, y squared equals 4. Square root each side, y equals plus or minus 2. So we found a possible combination here. When x equals 5, y can equal plus or minus 2. And there will be one more possibility like that. We have to plug in -1 for x now. So let's bring this where we have some room, let's say over here. When x is -1, we get -1 squared, which is 1, plus 2y squared equals 33. Subtract the 1, get that 2y squared equals 32. Divide the 2, get that y squared is 16. And then when you square root, you'll get that y is equal to plus or minus 4. So now you have another possibility. When x is -1, you can have plus or minus 4 for y. So those are all of our answers. Now, it is very important not to mix these up, because when x is 5, y cannot be plus or minus 4. Y can only be plus or minus 2. So it's very important to keep these answers together in their own sets. So anyways, this problem got pretty juicy. I hope you guys feel more comfortable with elimination now. For more ACT or SAT help, be sure to visit www.e-ztutoring.com. Thank you guys and good luck.